All right, this is the 8.7 Day 2 video. So the objective of this lesson is to divide numbers in scientific notation. So in the previous day, we looked at multiplying numbers in scientific notation. Today, we're going to work on division. So similar to yesterday, we're going to review dividing exponents. So remember, 3 to the 8th meant that we have 8 3's multiplied together in the numerator. 3 to the 6th meant we have 6 3's multiplied together in the denominator. And we can cancel out 6 pairs of 3's, leaving us with 3 to the 2nd. Okay. Similarly, in number 2, 10 to the 5th meant that we have 5 10's multiplied together in the numerator. 10 to the 3rd meant we had 3 10's multiplied together in the denominator. We would get 3 pairs of 10's canceled out, leaving us with 10 to the 2nd. Okay, so we can look at kind of our rule for this, and when we have division with powers, the exponents are getting subtracted. So 8 minus 6 gives us 2, 5 minus 3 also gives us 2. Okay, so we want to think about the rule of subtracting the exponents. Okay, and we can apply that to problems like number 3 and 4. So even though we have negative exponents, we can apply the same rule. So your base stays your same, and your exponents are getting subtracted. So negative 8 minus 6. Negative 8 minus 6 gives us negative 14. So this would be 3 to the negative 14th. In class, when we talked about our exponent rules, we did not leave things with negative exponents. However, in scientific notation, we will be leaving them. So I'm just going to leave number 3 as a negative value. In number 10, in number 4, we have 10 to the 5th divided by 10 to the negative 3rd. So your base stays the same, and we're subtracting exponents. This would be 5 minus negative 3. So be careful, because that's a negative 3, we would do minus negative 3. Well, minus negative is the same thing as addition, so we can think of this as 5 plus 3, which would be 10 to the 8th. Okay, so we'll be using that when we're dividing our numbers in scientific notation. So for example, we might have a problem like 3.5 times 10 to the negative 4th over 5 times 10 to the 7th. We're going to split this up almost into 2 different parts. So we have 3.2 divided by 5, and then we have our powers of 10 would be divided. So 3.2 divided by 5, you would set up your division problem. Okay, and you'd end up with 0.64. We'll go through another one slowly. And then our powers of 10 would get subtracted. So we would have negative 4 minus 7, which gives us that negative 11. Okay, similar to yesterday, our final answer is not in scientific notation yet, so we need to adjust it. We need to move our decimal over to make the number bigger by 1, so our exponent gets smaller by 1, which would turn into 6.4 times 10 to the negative 12th. Okay, we're going to go over 4 examples step by step on the back. Okay, so again, we're finding the quotient, meaning dividing, and then we're going to write our final answer in scientific notation. So in number 1, we have 6 times 10 to the negative 2nd divided by 5 times 10 to the 5th. Okay, so again, we can kind of split this up into 2 parts. 6 divided by 5, and then 10 to the negative 2nd divided by 10 to the 5th. So we would need to take 6 divided by 5. Well, 5 goes into 6 once. Multiply, subtract. We would need to add our decimal and bring down a 0. 5 goes into 10 twice. So this would give us 1.2. And then our exponents are going to be subtracted. So negative 2 minus 5, which would give us negative 7 as our exponent. This answer is in scientific notation. 1.2 is between 1 and 10, so we don't have to adjust our final answer at all for this one. All right, number 2. We have 2.7 times 10 to the 5th divided by 9 times 10 to the 6th. If we want, we can rewrite this kind of in the other format with a fraction bar representing our division. Okay, and then again, we're going to think about 2.7 divided by 9, and then 10 to the 5th divided by 10 to the 6th. So we can come to the side and take 2.7 divided by 9. 9 does not go into 2, but 9 goes into 27 3 times. So this gives us 0.3. And then our exponents would be subtracted. So power of 10 stays the same. 5 minus 6 So we would have 0.3 times 10 to the negative 1. This is not in scientific notation, so we need to move our decimal one time to give us just a regular whole number 3. We just made our number bigger by one spot, which means our exponent's going to get smaller by 1 to turn into negative 2. Number 3, we have 8 times 10 to the 5th divided by 4 times 10 to the 5th. So again, if you prefer, you can rewrite it using your fraction bar as division, whatever makes the most sense for you. Okay, so we have 8 divided by 4, and then 10 to the 5th divided by 10 to the 5th. Well, 8 divided by 4 is 2. It's just going to be a whole number. And then our exponents would be subtracted. So 5 minus 5 would give us 2 times 10 to the 0. If you remember from many days ago, any number to the 0 power is 1. So we can write this as 2 times 1 or just regular 2. Okay, depending how Big Ideas wants you to write this, it might want you to accept your answer like that. It might want you to simplify it down to 2. So kind of 2 options to try. All right, and then the last one, we have 9 times 10 to the 7th divided by 3 times 10 to the 2nd. So again, if you prefer, you can rewrite it using your division bar. Okay, and then we have 9 divided by 3 and 10 to the 7th divided by 10 to the 2nd. So 9 divided by 3 is 3. And then our powers of 10 would be subtracted, so 7 minus 2. So this would give us 3 times 10 to the 5th. And that is in scientific notation. Our 3 here is between 1 and 10, so we are good to go.